Good day, everybody. I'm Patrick Bekel, Commercial Director of VONK. Welcome to this webinar on hybrid power systems for remote, onshore and offshore applications. I'm proud to introduce you to Dave Oesterholt. Dave studied in the Netherlands at the Technical University of Twente, and he received his master's degree for chemical engineering. He has 30 years of experience in the energy and oil section. He had technical commercial roles at Gastech, DNV and Kiva, and I'm very proud to have him in the team at VONK for 2 years now. Dave is a specialist for the production and the utilization and storage of green energy. Dave is going to be your host today in the webinar on innovations and approaches for remote energy utilization. Enjoy your webinar and good luck, Dave. Dave.
Thank you very much, Patrick, for introducing me. Welcome everyone to this webinar. Good morning, some of you, good afternoon, and some even good evening. Thank you very much for tuning in this next webinar in our VONK webinar series. Like Patrick said, this is one on hybrid power systems, how they can help you reduce costs and CO2 emissions. In the next half hour, I would like to take you through this presentation, and the subjects are, I'll first shortly introduce VONK, but before I start actually the webinar, I have to say that you can leave your questions on the right side. You probably already discovered the chat box. If not, you can open it by clicking on the red label with the 3 dots on, then the chat box will open. Please leave your questions in there. I will come back to that later after my presentation, which will take about half an hour. And then we'll happy to answer your questions. My dear colleagues around me, on safe distance of course, they are collecting the questions, and we will come back to that later. So yes, this is the agenda for today. I will shortly introduce the company I work for. I will then explain what we mean with remote, off-grid, industrial, renewable power systems or hybrid power systems. What is it actually? What do we mean with it? Then I will tell you a bit more about certain use cases, HPS offshore and onshore. For which application do you need which kind of HPS? And finally, I will do a recap. Yeah, let's look at the company VONK I work for. I'm proud to work for VONK. Already exists more than 80 years. It started with Mr. VONK, hence the name. And meanwhile, we have gone through quite a period of time, more than 80 years, build up experience and capabilities in the area of electrical and instrumentation, power conversion, and control and automation. We have been part of different groups. Now we are part of the Industry International Group, and we are based in different places in the world with head office in the Netherlands. We are specialists in power conversion, but this slide shows you that we are also specialists in power distribution, control, and automation. And all these disciplines come together also in industrial off-grid hybrid power systems. You can see on the left, we are doing this often in a containerized solution. There's a power management system inside, of course, control and automation systems. And on the next slide, there are some examples also of our special, very special power solutions, power conversion solutions, I should say. They are actually being applied in different industries like uranium enrichment, hydrogen production, green hydrogen production. Large electrolyzers are fed by our power converters, and also in the defense, and naturally also in the oil and gas business. Which brings me to the subject of today, the hybrid power system. What do we mean with it? This gives you an overview of the total system. It consists of renewable energy generation. That's the main source of energy generation. Sometimes, if needed, also a backup will be installed. We store the energy that is produced in excess. So when you produce more than needed for your processes in your installations, we can store it in different ways. I'll come back to that later. And you can use the energy for different applications. For example, your offshore platform or your onshore installation, but also in telecoms, also for your block valve stations, also even to the grid for balancing purposes. First, I would like to go to the heart of the system. which is the VONK power management system in this case. So the power management system is actually dealing with a lot of things. It will take care of battery charging and discharging. It will monitor the state of charge of your batteries. It controls the switching on and off of your backup generator. Can be a gas, diesel driven or hydrogen driven, like I will show you later. You can also optionally have an electrical distribution system, actually controlled by the power management system. It will tell you about the states of the remote, through remote monitoring and control, the status of your different processes at your installation. Optionally, we can add load shedding also to the mix, and it can have some control and automation functionality. Most of the times we will then deliver such systems, or HPS systems are delivered in a plug-and-play solution, containerized. Everything is fitted before, tested before it is actually transported to site. This gives you the opportunity also to work very flexible. We have a modular approach. Different sizes of containers number of containers are available. And this way we can optimize design, actually also adaptable to the space available and the specific situation you are in. Of course, you need the energy from somewhere, and we preferably, of course, generate the energy fully renewably. There are different options. You can do this. Naturally, solar is the preferred option, but also wind can be put into the mix of renewable energy generation. Here at this slide, you see a few examples how the solar panels actually can be mounted, can be installed, for example, on offshore wind farms, I should say platforms, of course, offshore platforms for oil and gas production. You can put them on the side vertically, you can put them on top under different angles, different orientations to the sun, and also in the situation of land, there are different possibilities. You can also add wind turbines to the mix. Like I said, there are different configurations available. You see here on the left bottom a helix type of wind turbine. You also see the picture on the right at the bottom, the more traditional wind turbine with 3 blades. You can also see it in the top right photo above me there. And we also have a more horizontal configuration of turbine available. They have different powers up to about 10 kilowatts. Regarding solar, it's also possible to have floating systems. And this, of course, for your offshore installations. And this slide shows you a few examples. There's been a very successful pilot in the Netherlands, just off the coast of the Netherlands, with a 17 kilowatt power installation. It survived several storms, among which the infamous storm, I should say, the Ciara last year, beginning of last year. And on the right photo, you can see more the circular configurations, floating arrays of panels. They actually produce a lot more energy, so you can also cover larger loads on your platforms. Just before I go to the next slide, I should say something about cleaning such panels. At offshore, that is not such a problem. Droppings from birds, for example, are washed away by rain. But in a desert area or another onshore area situation, you can have problems with that your solar panels get dirty. There are different systems to solve this. One of them is a robotic system, automatically cleans your panels. Another one is remotely actually monitor the performance of your panels, and if it comes to a critical minimum performance, you can then intervene, send your maintenance teams out. Which brings me to the next component of a hybrid power system, a very important one, that is the energy storage. Of course, when you produce the energy and the power management system converts it into the load needed for your processes in your different your specific installation, you will also produce sometimes more than that, and you can store that in batteries. And at times when your renewable energy is not sufficient, you can then, through the energy storage, use that energy through the power management system to actually provide the load to your platforms. There are different ways for energy storage. Most commonly used are batteries. Batteries is just one term, but there are very different types on the market. And it is really dependent on the situation you are in, which option would be the most preferable. We always try to optimize our battery system to the specific situation. And then it is very important to know what is your operating temperature, what's the daily depth of discharge possible for each battery type. Of course, price, which is not in this table, is important. Recyclability is also a very important factor. If it is allowed or not. In many occasions, offshore lithium-ion is still not allowed. So in this table, you can see the different properties, typical application ranges for the three most commonly used battery types: lead acid, nickel cadmium, and lithium-ion. In this case, the lithium ferrophosphate should be a 4 behind the PO, but it's the lithium ferro battery type. It has the highest energy density. You can also discharge it further than other batteries. I should say maybe something more about the daily depth of discharge. That is the percentage of the capacity you can use per day. So till what percentage you can actually discharge your batteries without jeopardizing the lifetime of the battery. For example, in the platform situation, we discharge our batteries, the lead acid ones, to 50%. You can go lower than that, but you will drastically reduce the lifetime of your batteries, and you do not want to exchange them too often, of course. Temperature is also important. When you are more in a situation of hot climate, you would tend to look at nickel cadmium, for example. But what I'd like to try to say is, per situation, really have to look at what kind of battery is available, what kind of battery is suitable, and take all the different factors into account. I come now to a very new innovation that we add to the hybrid power system, and that is the hydrogen storage unit. It is a really nice system to actually complete your system or an addition to your HPS. What it does is the following. At good solar days during summer or spring or autumn, the batteries are full already about 10, 11 in the morning. So the excess energy you then produce, which you do not need for your loads, you can then send through this system, convert it into hydrogen that you can use in wintertime, for example. This way, you can actually leave any emergency backup completely behind. It will replace your emergency backup. By introducing such a system, you can also do with less solar panels, and it will have a smaller footprint. You can then also go to less batteries, or the other option is improving the battery lifetime you already have, the batteries you already have. So how does it actually work? Inside is a system called the electrolyzer, converting the renewable power into hydrogen and oxygen. It needs water, of course, it's an electrolysis process, but you can only, in this case, with a 1,000-liter tank, last for many years, till the next interval for maintenance, which is every 2 years or even less, longer periods even. But what is nice about this system is the same electrolysis stack is also fuel cell the other way around. So when you stored your hydrogen, you can use it the other way around and use the fuel cell generator, or the same stack as a fuel cell generator, generating energy when you need it in winter or during long periods of fog. The compressor used to bring the hydrogen to the desired pressure, in this case 300 bar. I can show that in the next slide actually. The next slide actually is an 800-liter system in which you can store effectively 293 kilowatt hours electrical in this case. And if you, so that's quite a good amount of energy available for the winter time. The fuel cell generator in this case produces 8 kilowatts electrical power, but you can also, because it's a fuel cell, it will also generate heat. Maybe you can also use it at your installation as well. We are working together with our partner also to make a bigger system, to higher kilowatts, tens of kilowatts, maybe even 100 kilowatt. So this is a good addition to the HPS system. When I look at the total system, that's also including backup generation. I did not go into much detail of that, but sometimes necessary to have some backup available. There can be a diesel generator or a gas generator. It can also be a fuel cell generator, as I just explained. But what is very important for the total HPS system is that you optimize it. And during the design phase, we have a simulation tool that does that for us. So what we do is we look at the current or the specific situation regarding solar. I do not have a pointer, unfortunately, but I'll try to explain the graph anyway. The blue line is actually the solar energy generation. So you see actually a kind of waveform which follows. This is a year, by the way. So you see a year on the x-axis. So you see a wave following the seasons. There are some peaks, of course, on the good solar days, and there are some dips on the worse solar days. The gray line underneath that is your charge of battery, your state of charge. At a bad solar day, you need more battery power. What can happen then is your battery gets close to the daily death of discharge, which is the yellow line. And you do not want that. You do not want to cross that line, or at least as little as possible. What it does, when this threatens to happen, the power management system kicks in, takes over control, switches on your backup generator, which can be a hydrogen unit, a gas or diesel backup, or a larger battery package. And that's that is shown here as the pink peaks. What is good to know that it is actually really an emergency backup. It kicks in only when needed. That will be a couple of times. So for example, when it is a fossil fueled one, you only need to refuel after a long time till the next maintenance period. Could be only after years, 2-3 years. So that's good. You do not have to go there that often. And the hydrogen production, if you use a unit like I showed before, the bidirectional hydrogen unit, the hydrogen production during summer will be sufficient for your running hours of your processes at your installation in winter time. Let's go to some use cases now. You produce this energy to be used, of course, in a installation. I'll first give some use cases regarding offshore applications. There are different ways to electrify platforms offshore. Today, I'm focusing on the off-grid version, renewable energy, no cable to the platform. But there are also other ways, as you can see in the top, but these are for the very large platforms. In this case, the new Equinor Johan Sverdrup field has been installed and now put into operation last year, beginning of the year. And that is connected to shore via a cable, and the electricity fed into the cable is completely renewable, it's green. Another way of doing it is by substations that are installed offshore as well, to harvest the energy produced from wind farms, and you can connect with your platform via an umbilical to one of these substations to power your platform. But today we're talking about the offshore, the off-grid industrial renewable installations. You can introduce an HPS on your platform during different lifetime stages. We already see examples when they have a new build. You can power minimize, power optimize your platforms in such a way that you can fully power your platform renewably. Maybe some backup power, but in many cases also 100% renewable energy. You can have an existing platform, which you can then also put a HPS system in the mix to cover total or part of the load. What we also see often is in the late life of the assets, when the field starts to produce less gas or oil, it becomes economically not so viable anymore to operate the platform. Then you can decomplex the platform. First, I will show in a minute what that means, and then introduce an optimized HPS system to cover the remaining load. What you can also do once you have stopped production, because whatever reason, it's not economically viable anymore, or the field is empty, depleted. It takes a while before the platform is decommissioned. Also in that situation, you still need power. You still need power for your nav aids in the cold stack situation and some remote diagnostics, but also what they call warm stack, that you still are obliged to monitor the well pressure. In that case, it's also very convenient to put an HPS in place that takes fully care of that. Nowadays, what you also often see is that platforms are being reused for different reasons. One of them is to produce green hydrogen on the platform on a larger scale, using seawater being desalinated through electrolysis, renewable power nearby from wind farms connected to the platform, produce hydrogen and actually transport that through the existing pipelines to shore. A very good green development. Another one is from shore to platform, captured CO2 through the same pipeline you used before for your oil or gas, and inject it in the depleted field. We also get questions now to put an HPS on such platforms. But like I said, also for assets that are in the late life, to make them economically viable again, you can first perform a simplification step, or also called the decomplexing. What you then do is you relocate certain processes to a central platform. So your satellite platform is actually being stripped from processes and also installations. For example, in this case, they took away the heli deck, they took away the crane, and the different installations you can then remove. You can leave them on if you want, and then cover them with solar panels, and you go from a manned to a normally unmanned platform. And then you can introduce an HPS system to cover the remaining load still necessary for the processes remaining and for the nav aids for some other purposes. So then you can introduce solar, wind, or the mix. We have done this in the southern and North Sea off the shore of the UK. In this case, a Lehman Echo platform being decomplexed by Shell, one gas. So on the left, you see the old situation. On the right, the new one. It went from a heli access to a marine access, which is visited by a walk-to-work ship much less frequently than a helicopter needed to go to the platform before. It's instead of powered by fossil fuel generators, now fully powered by 100% green energy. It went from manned to unmanned, and the maintenance interval going there every month even to only once every 2 years. So there you can really save cost and also CO2 emissions, reduce the CO2 emission drastically on the platform. And in this case, even more than 90% of OPEX has been achieved by the combination of decomplexing and introducing the HPS system. You can see on the next slide the specifics of these platforms. We have not done Lehman Echo alone. We have also done Lehman Bravo and Delta platforms. Very similar situation. These platforms, the remaining load could do with 7.5 kilowatts, maximum 7.5 kilowatt continuously. It needs then about 150 solar panels. There are some backup generators in this case, special request of the customer. There's a battery system in place that stores 120 kilowatt hour of available energy at a 50% daily depth of discharge. Of course, the power management system is controlling the whole situation between generation, storage, and load. It has interfaces to a control system and a very nice remote control system as well. So you can actually monitor and control the processes on a distance, from a distance, remotely. Navigational aids has been renewed as well in this case. And as you can see in the picture, these red containers, they're fully plug and play. They were already pre-fitted, prefabricated, pre-tested, went to the, transported to the platform, put on the platform, connect it, install your panels, and just push the on button. You just saw three containers still. We have the modular approach, flexible. We even got to a more compact version where 2 containers are sufficient. Like I said, also after production, before decommissioning, can be several years that the platform is still at sea, and you need also power for that. For the cold stack mode, navigational aids, some remote monitoring, but also for warm stack, where you also have to control the pressure in your well. These loads are smaller, so we have a very compact system for that. Solar panels will cover it all. It's also able to be relocated, again, for the next platform, the next situation. You can add navigational aid system or not, depending on do you leave the old system on the platform or do you need a new one. And it has a very small footprint. Which brings me to the next use case, an onshore example. In this case, an onshore gas well, a typical onshore gas well. A gas and water mixture is pumped up via downhole submersible centrifugal pump. It's then the water and gas are separated. The gas is your product, and you, in this case, use a part of the gas to fuel your gas engines, which are actually kind of car engines, 4, 6, or 8 cylinders in this case, which drive an hydraulic package. The situation here, as you can see from the lot of the red text, is not ideal. You have reliability issues, you have a lot of maintenance, you have emissions from your gas engine, you have noise pollution. Farmers nearby, landowners nearby can start complaining about the noise of your generators. You also have production losses. And like I said, it's very maintenance intensive. You could solve all these issues by introducing an off-grid industrial renewable installation in combination with an electrical motor. This is what the situation is then. You harvest the energy by solar. In most cases, there's enough space around your system for solar to be installed. Can be also very easily locatable when you only need it temporarily. The HPS is put into place, well, with all the advantages I mentioned before. Very limited maintenance. There's no noise, no restarts. You don't need any of your produced gas, the product, so you don't lose any money there. And it's a very green solution. In this case, you can have different options. There may even be more than 2 options. You can also introduce a hydrogen unit, for example. But in this case, when you only need combine your solar energy and battery, a large battery, then you need quite a large battery to cover it. Also the situations where you have these dips that you threaten to reach that daily death or discharge too often for your batteries on the bad solar days, so to say. But it has practically no maintenance. In some cases, it then might be needed to add a small emergency backup. That gives you the advantage that your battery size is not too large. We, of course, will use a low emission emergency diesel gas engine, or we can also introduce a hydrogen unit, fuel cell generator. And in most cases, backup will only run for testing purposes. There's limited maintenance on the genset. And yeah, so that's also an option to consider depending on the situation. Which brings me to the one but last point of the agenda. Which HPS would then suit your typical situation? It's dependent on a lot of factors. Not listed here is, of course, what is the goal? What do you want to achieve? Lower OPEX, lower CO2 emissions, how much lower? A combination of those two. And then it's, of course, important to know what is your power requirement? What does your load profile look like? Where are you located? Towards the sun. I mean, near the equator, it's there. But if you're in the Nordic area, then it's very low. So we have to take that into consideration. How is your installation, for example, an offshore platform, oriented towards the sun. Where can you put your solar panels? How much space do you have for your solar panels? How much space do you have for your containers to put on your installation, on your platform, for example? Which availability do you require? And you could consider first to decomplex or simplify your installation before you introduce an HPS. So the combination brings you the optimized level of OPEX reduction and CO2 emission reduction. And last but not least, I haven't mentioned this before, but it's important, of course, when we talk about oil and gas. What about the hazardous areas? What about the zoning? What about the EX requirements? I put a separate slide on this, some notes on the HPS for such hazardous area application. We have a very flexible design, or HPS can be configured in a flexible way, modular, to meet the requirements of your EX Zone 1 and EX Zone 2 in this case. We can use EX certified panels, solar panels. We can use EX certified equipment boxes in which the different components are installed in such a fashion that allows you a maximum serviceability, and by applying multiple standard equal components. Like I said, we can also split the HPS in different modular parts, containers, to meet the available space you have on your platform, meeting the different hazardous area requirements. Which brings me already to the last slide, the recap of today. I hope I was able to provide you some new insights regarding hybrid power systems, 100% renewable industrial off-grid power to certain installations, onshore and offshore. What you can achieve with it is you can decarbonize your processes by even using up to 100% renewable energy. You can considerably reduce your OPEX. You can reduce your maintenance interval drastically as well, often only once to 2 years. You can achieve very high availability, even higher than what I put here, depending also on the requirements, on your requirements. Very reliable system. And of course, also important, you can remotely control and monitor it. This brings me to the end of the presentation. I thank you very much for your attention. And of course, it's one note I would like to give is involve an HPS specialist or expert as early as possible in the process. And I wouldn't be standing here for VONK if I wouldn't tell you that we can be your consultant in the feed phase or provide an HPS system that you can buy or lease. Also important to know. Let's have a look at the questions. I see we have a question from Mr. Mohammed Mutahulali. Thank you very much for the question. What is your protection against marine growth on the floating surfaces? Yes, that is important to know what to do with the fouling of you. I think you mean panels in this case. Of course, it starts with a suitable coating of the different panels. And the same solutions that are utilized for boats can be applied, for example. Yeah, so you can put a surface on that actually will wash off very easily. But to be honest, we are not a specialist in anti-fouling. But we could come back to the question separately if you would like. Another question from Mr. Ahmed Fazil Mustafa Kamal. Does VONK manufacture the H2 storage as well? VONK can provide the H2 storage system as a part of our total system. Yes. So we might not manufacture everything, but we will design, engineer, and provide you with the total package. VONK indeed delivers the complete package, yeah, so to say, including the H2 storage system to store the hydrogen from our bi-directional hydrogen unit, and it will retrieve it when energy is required again. I hope that answers your question. I have a question here from Juan Perez. What kind of transformers do you use? Well, the HPS setup does actually not include transformers, but for conversions, electronic converters and inverters are applied. I hope that will answer your questions. Regarding these questions, it's important to know that you can also email us, and we can also have a one-to-one conversation, of course. Just a little sip of water. I'm very glad that actually a lot of questions came in. There's another question here from Mohammed Al-Labati. I hope I pronounce all the names well. How does the HPS weight up comparing to diesel generators economically? We understand 100% replacement is not economical. Is that still the case? Well, you have to look at the total cost of ownership, of course. Well, we already have multiple sites in which we replaced the diesel gensets with the hybrid power system. In many cases, 100% replacement is practical, and thus 100% CO2 reduction can be achieved. Especially when you include the OPEX in the comparison, you will see the economical benefits of the HPS system. It drastically reduces the total cost of ownership, and you can have a very good return on investment on it. I see a question here from, I hope I pronounce it right, Ayodeyi Okele. What is the smallest capacity HPS? Well, it's a simple answer. What do you like? The system is built up in components that are sized for the actual application or load. I showed earlier the HPS decom, we call it, for the offshore situation after production, can also be onshore. There can be up to 1 kilowatt or even lower, depending on what you would like. I see another question coming up from Mr. Mustafa Siri Tanribilir. Hello, how do you keep the solar panels clean for high power output? I mentioned it briefly in my presentation that we do have various ways to keep them clean in offshore locations. And nature helps us a lot, like I said, via rain, and the bird droppings are being removed. In the last 4 years, we did not measure a decrease in solar production offshore at all. For desert environment, yeah, then it can become a problem. We can provide you with a robotic cleaning system, or in addition to that, of course, our system is remotely connected, and it will warn us if required, if the solar performance is not met anymore. Then we can intervene. I have a question from Kamulidin Sakaria. How frequently do you replace the batteries based on this configuration, considering its daily cycle of depth of discharge? That depends on it. And of course, replacement or lifetime of the batteries is predicted based on its use. This starts with the applied type and indeed the daily depth of discharge, but also the operating temperature and the daily cycle. In the table, I gave some indications of the lifetime, which in most cases is at least 10 years, but can, by doing the right design, also go up to 20 years. Another question from AJ. Is your hydrogen power storage unit suitable for hazardous area installation? At the moment, it's not, but we're working on that, so that it will be also suitable for a hazardous area. I see a question from Steve Windass. Have you installed HPS and particularly the solar to hydrogen to operational normally unmanned installation platforms, and not just cold or warm stacked platforms? Not at the moment, but we are working on a pilot to do so. But we are already, of course, if you like it, if you want it, we can build it. So it's not that we have to redesign this or something. It's available. And regarding the hydrogen unit, we are now in the pilot phase. So that will be the next step to go also to industrial rollout. So far, 4 pilots have been running successfully with a bidirectional hydrogen unit already. Okay, a lot of questions are being asked. We are, of course, we have recorded, my dear colleagues have been typing and copying and pasting a lot. We will collect these questions and come back to you with the answers. I see, let's have one last question from Mr. Ayodeyi Okele. In warm climates, how do you dissipate the heat that would build up in the container? We have very good experience with containerized solutions. So we simply will do it by ventilation, or we apply coolers that are run on the excess solar that will be available during the hot and sunny day. So the coolers will then run also on renewable energy. An alternative is passive cooling that can also be done. So a lot of questions. So I hope that means also that it is a very interesting subject. Like I said, we are available. Just contact us. We will have one-on-one conversation and take it from here. I thank you very much for your attention again, and I wish you a very good day. Bye-bye.